Okay, so good morning, students. And as we have done the hardness of water, we have seen that hardness of water is due to the different salts which are present in the water sample. That is calcium and magnesium salts in form of chloride, sulfates, nitrates, carbonates, and bicarbonates. Okay, so already we have studied, we have determined the hardness also with the help of EDTA method, all three types, that is temporary, permanent, and total hardness. Now, as we have determined that there is a hardness in the water sample and we cannot use it for certain purpose. So what we have to do now, we have to soften that water. Okay, we have to soften that water so that we can use it for different purposes. So what is this softening of water? That is actually the process of removing or reducing concentration of hardness causing salts from water is called as softening of water. So whatever the hardness causing salts are present, you know that which are the salts are present in the water sample. So all that hardness causing salts, we have to either remove it from the water sample or we have to reduce its concentration. So removing of all water's hardness causing salts from the water sample is little difficult. So at least we can reduce the concentration of water. Okay, reduce the concentration of hardness causing salts from the water. So the same is actually the softening of water sample. So the process of removing or reducing the concentration of hardness causing salts from water is called as softening of water. So basically we are going to purify the water so that it can be used for drinking, cooking, industries, etc. So there are three different methods by which we can do the softening of water. That is lime soda process, zeolite or permuted process, and the third is ion exchange, or it is also known as deionization or demineralization process. So these are the three methods by which we can do the softening of water. But from your syllabus this time, lime soda process and zeolite method has been removed. Okay. So अगर हम लोग करते lime soda or zeolite, so it is very lengthy process also, and many reactions are involved in lime soda process. So the theory was also in there and numericals was also there. But now as time is very less, so this lime soda process and zeolite process has been removed, and only we have to study the ion exchange. We have to study ion exchange process, which is also known as deionization or demineralization process. Okay, so deionization means removal of ions. Demineralization means removal of minerals from the water sample. So that's why we call it as deionization or demineralization process or ion exchange process. So in this case, ion exchange will take place. There will be exchange of ions. Now, if I ask you that suppose in water sample, hard water sample, which are the ions present in it? Yes, students, can you tell me which are the ions present in the water sample? Yes,
H plus ion, ma'am.
yes,
OH minus,
yes, or
CO3 minus,
yes,
SCO3 minus.
yes, very good. और कौन से है? So as we know that the hardness causing salts are calcium and magnesium in form of chloride, sulfates, nitrates, carbonates, and bicarbonates. So that means, and plus other heavy metal ions. So that means what? calcium is present, calcium 2 plus, magnesium 2 plus, iron, sodium, aluminium. These are the cations which are present. Similarly, we have anions also like chloride, Cl minus, sulfate, SO4 2 minus ions, carbonate, CO3 2 minus, then bicarbonate, HCO3 minus. Okay, so that so nitrate, NO3 2 minus. So that means your cations and anions are present in the hard water sample. So cations कौन कौन से present? Now anyone in the hard water sample I am talking about कौन कौन से cations present है, कौन कौन से anions present है? Yes students. बोलो बेटा. Just now I told you na which are the cations and anions are present in hard water sample. Huh? No one knows.
Ma'am,
हाँ.
cations means SO3 minus.
नहीं, cations positive charge होते हैं ना बेटा.
Okay, ma'am.
Cations are positive charge, anions are negative charge. So you are saying anions, HCO3 minus, then
CO3 2 minus.
CO3 2 minus, then
OH minus.
OH minus, SO4 2 minus ions, NO3 2 minus ions, yes,
Cl minus.
Cl minus. So these are anions. Cations कौन कौन से present है?
plus
हाँ,
Mg2 plus
Mg2 plus, yes,
K2 plus.
calcium 2 plus, और calcium and magnesium, of course it is there. Along with that, other heavy metal ions also are there, no? So which heavy metal ions can be there? Positive charge. Sodium, Na plus, iron, Fe2 plus, aluminium, Al3 plus. So these can also be present in the water sample as hardness causing salts. So hardness causing salts जो भी है हमारा वो सब like calcium chloride, calcium sulfate, magnesium chloride. So all these can be ionized in form of Ca, like calcium chloride, Ca2 plus and 2Cl minus ions. Calcium, magnesium sulfate, Mg2 plus and SO4 2 minus ions. So all the hardness causing salts can be ionized in form of cations and anions. So these cations and anions are your hardness causing ions. So here in ion exchange method, we are going to deal with the ions present in the hard water sample. Okay. So ion exchange process. So first and second, as I told you, lime soda and zeolite, that is not there in your syllabus, not the theory as well as the numericals. Both are not there. So we are going to study the third method, that is ion exchange process. Now in ion exchange process, what is going to happen? It is a process in which a reversible exchange of ions occur between the stationary ion exchange phase and the external liquid mobile phase. Okay, so now here we have divided the we have two phases, that is one is stationary and other is mobile. What do you mean by stationary? Fixed. Okay, रुका हुआ. और मोबाइल मीन्स जो मूव होता रहता है, जैसे मोबाइल एम्बुलेंस रहता है. ओके, सो वैसे वो मूव होता रहेगा. सो हियर वी हैव two different phases. एक कौन सा स्टेशनरी आयन एक्सचेंज फेज और दूसरा लिक्विड मोबाइल फेज. So we have two phases here. Now the reversible exchange of ions of the hard water sample is going to take place between these two phases. ये दो फेज के बीच में हमारा रिवर्सिबल एक्सचेंज ऑफ आयंस होगा. Okay, now it will be more clear from this reaction. See here, you can see A and AB plus CD. Okay, AB plus CD. Suppose AB is the ion exchange phase and CD is the liquid mobile phase. Okay, so now these are the two phases, and from these two phases, your ion exchange process will take place. So here you can see that from the ion exchange phase, stationary, जो रुका हुआ एक ion exchange phase है, उसमें से B हमारा मोबाइल लिक्विड फेज में जा रहा है और लिक्विड फेज से आपका D स्टेशनरी फेज में आ रहा है. ओके, सो दिस इज योर बेसिकली द रिवर्सिबल एक्सचेंज. यहाँ पे आपका रिवर्सिबल एक्सचेंज हो रहा है. सो हियर यू कैन गेट द प्रोडक्ट एज AD plus CB. Okay, so you can see that the blue color ion of both these phases. Now this AB I am calling it as stationary phase and CD I am calling it as mobile phase. So these are the two phases. Okay, so out of this stationary phase, B ion is shifting to mobile phase and D ion from mobile phase is shifting to stationary phase. So in the product, you can see that the ions has been exchanged and we have got in the stationary phase AD and mobile phase as CB, which was not same earlier. Okay, are you getting it, students?
Yes, ma'am.
Okay, so in this way, there will be exchange of ions between these two phases. Okay, तो जो हम लोग ion exchange process पढ़ने वाले हैं, when we will see the process completely there, you have to understand that there is exchange of ions going to take place between stationary ion exchange phase and external liquid mobile phase. Okay, so here you can see again in the diagram that we have in this blue color all calcium and magnesium, calcium, magnesium, sodium ions and present in the hard water sample. And we are going to add this resin. So this is your mobile phase. मतलब पानी में ये सब है. So this is mobile phase and these are the resins. Resins are nothing but polymers. We will study in detail in the next slide. So resins are basically polymers. So they are again having another ions and they are going to exchange, the mobile phase is going to exchange their ions with the stationary phase. So resin is acting as stationary phase, water is acting as mobile phase. So between these two, there will be exchange of ions and we will get these kind of water sample which will be free from your calcium and magnesium ions and this will become your soft water. तो आपका बाद में जब प्रोडक्ट आएगा तो क्या होगा, रेजिन इज हैविंग ऑल योर कैल्शियम मैग्नीशियम आयंस, वो सारा एब्जॉर्ब कर लेगा और आपका पानी से एंड योर वाटर विल बिकम सॉफ्ट वाटर. ओके स्टूडेंट्स, इफ यू हैव एनी डाउट यू कैन क्लियर इट आउट. Okay, now we will see the properties of ion exchange resins. Okay, so in ion exchange process, we are going to use ion exchange resins. Now these ion exchange resins, what are these? What are their properties? How it looks like? All that we will see first. Okay, so what I am telling you that in ion exchange process, we are going to use ion exchange resins. Now, what are these ion exchange resins? What are their properties? So that we are going to study now about resins. So these are basically resins. Resins are nothing but polymer. They are high molecular weight, very long chain, high molecular weight, organic polymers. okay, in form of either granules or in form of small granules we can use, or we can use the shredded type of resins, but these are nothing but polymers. Okay, so here they are these resins, they are insoluble. That means they cannot dissolve in water easily. They are cross linked. Okay, cross linked means they have very complicated structures. Then they are long chain, high molecular weight. They are having very long chain carbon chain length, that is very long, and high molecular weight organic polymer. They are permeable due to their microporous structure. What do you mean by permeable, students? Do you know what do you mean permeable? Yes. Yes, beta. Anyone? Do you know what permeable?
मीन्स मैम
Ma'am, to
उसमें के
pass.
से बाहर
क्या बोले, फिर से बोलिए.
मतलब जो चीज है वो आर पार हो सकती है ऐसे.
Permeable means like your have you studied osmosis process in 11-12?
यस
Osmosis पढ़ा है?
Yes, ma'am.
So in osmosis, there is a central barrier which is a layer in between, and that layer is permeable. Permeable means it allows the ions to pass from it. वो वहां से उसको allow करता है to go from one side to another. Similarly, these resins, they have very small micropores, and through these pores the ions can migrate from inside to outside. Okay, so they are permeable. They allow the migration of the ions from inside to outside. Why? Due to their microporous structure, because these polymers, these resins, they have very small micropores in them, and because of that they can allow the H plus ions or OH minus ions or calcium magnesium ions to pass from water to resins, or from resins to into the water. So they are permeable. Then they contain functional groups. Okay, they contain functional groups. Can you tell me some examples of the functional groups in organic chemistry which you have studied? Yes. ऑर्गेनिक केमिस्ट्री में आपने कुछ फंक्शनल ग्रुप्स पढ़े थे, याद है? नहीं याद है? ओके, नो प्रॉब्लम.
Alkenes, ma'am.
Alkenes, these are basically hydrocarbons, beta. I am asking about the functional groups like acidic functional groups, alkaline functional
कार्बोक्सिलिक
groups.
एसिड अमाइंस
Sulfuric.
कीटोन्स.
Yes, very good. Yes. So carboxylic acid, that is COH. Sulfonic acid, SO3H. Then basic groups, OH, hydroxyl groups, OH minus. Then aldehydes, CHO group. Then you have basic like amino group, NH2, amines, amides,
कीटोन्स.
okay, ketones. So these are your functional groups. Okay, so these resins, they also contain some functional groups. Actually, they don't contain functional groups. We have to introduce that functional group into these resins. Okay, these resins, they don't contain the functional groups, but we have to introduce functional groups into it. So that means they contain functional groups attached to the chain which are responsible for ion exchange properties. Okay, so if the functional groups will not be attached to these resins, they will not act as an ion exchanger. If functional groups will be there, then only they can act as responsible for the ion exchange properties. Then only they can exchange their ions with the other ions. Is it clear, students? Yes? So
ma'am.
these are the properties of resins. Resins आपके क्या है? These are basically cross-linked, long chain, high molecular weight, cross-linked organic polymers. They are insoluble in water. They are permeable due to their microporous structure in which they have. Then they contain some functional groups attached to the carbon chain, and because of that, they can exchange their ions. Okay. So now we will see that what are the types of ion exchange resins. So as we said that they contain functional groups. So now based on the functional groups, we are going to divide these ion exchange resins. Okay. अभी हम लोगों ने बोला ना उसके पास functional groups present, and you have given me so many examples of functional groups. So based on these functional groups, which are the functional groups attached to them, based on that, we are going to classify this ion exchange resins into cation exchange resins and anion exchange resins. Okay, cation exchange resins and anion exchange resins. So first we will see what is this cation exchange resins. So cation exchange resin can also be written as RH2 or RH plus. This is the abbreviation of cation exchange resin. Okay. Now what this cation exchange resin will do? This cation exchange resin Am I audible?
No, ma'am, your voice was
Hello?
gone.
Now you are audible.
Yes, there was a call, that's why I was disconnected. Okay, now it's audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So cation exchange resins, the function of these resins are like they are going to exchange only cations with them. Okay. ये सिर्फ आपका cations ही exchange कर सकता है. That means which are the cations present in the hard water sample? We have which are the cations present in the hard water sample?
H plus,
Calcium, magnesium,
Magnesium.
sodium, iron, aluminium. So these cations, when they are present in the hard water sample, they can be removed with the help of cation exchange resin. Okay. तो ये cations को cation exchange resin ही remove कर सकता है. Now what this cation exchange resin will possess? They will possess the acidic functional groups. इनके पास कौन सा functional groups है? Acidic functional groups है. That's why here we have written RH2 और RH plus. Okay, तो COH group जो है उसमें क्या है? आपका H plus है. SO3H group उसमें भी H plus है. So all these cation exchange resins, they will have acidic functional groups. Okay, and because of these acidic functional groups, they can exchange their H plus ions. इनके पास they are rich in H plus ions. Okay. Cation exchange resins, as they have acidic functional groups, so they are rich in H plus ions. So they are going to exchange their H plus ions with the hardness causing salts, hardness causing cations.
मैम वॉइस नहीं आ रही है.
So the exchange resins are mainly
Ma'am, your voice
which
is not
polymer
clear.
or now it's coming. Now is it clear, beta?
Yes, ma'am.
Okay. So these are mainly what these cation exchange resins are. As Avi said that these are basically resins are nothing but polymers. But which polymer? Cation exchange resins are which polymers? So mainly they are styrene divinyl benzene copolymer. ये polymer का नाम है जो cation exchange resin act करता है. Okay, so this is the styrene divinyl benzene copolymer. It is a cation exchange resin, but these resin, they don't have any functional group. Styrene divinyl benzene copolymer is not having any functional group, and we know that for making it cation exchange resin, we have to add acidic functional groups into this polymer. Okay, so what we will do, how we are going to add these functional groups? By doing some reactions. Which reactions? By doing sulfonation reaction or carboxylation reaction. So when you will do carboxylation reaction with this styrene divinyl benzene copolymer, then carboxylic acid group will be attached to this resin. When you will do sulfonation reaction with this styrene divinyl benzene copolymer, sulfonic acid group will be attached to this polymer, SO3H, which will be then responsible to exchange their hydrogen ions with the cations present in the water sample. Are you getting, students, what I'm talking about? Okay. अगर नहीं समझ में आ रहा है किसी को, प्लीज you can unmute yourself and you can ask your doubt. So this is the one example I have shown. This is the example of styrene divinyl benzene copolymer. जो मैंने बोला ना आपको, ये आपका कौन सा रेजिन है जो कैटायन एक्सचेंज रेजिन हम लोग यूज करने वाले हैं, तो ये आपका स्टाइरीन डाइविनाइल बेंजीन कोपॉलीमर है. सो दिस इज द स्ट्रक्चर ऑफ स्टाइरीन डाइविनाइल बेंजीन कोपॉलीमर. सो यू कैन सी फ्रॉम द स्ट्रक्चर दैट इट इज अ लॉन्ग चेन कार्बन. ओके, देन इट इज क्रॉस लिंक्ड, पूरा आपका 2-3 लेयर्स, ये आपका देखो एक लेयर, सेकेंड लेयर, थर्ड लेयर. सो इट इज अ क्रॉस लिंक्ड पॉलीमर, high molecular weight. Okay, so this is basically a properties of resins which I told you. So it satisfies. So it is styrene divinyl benzene copolymer. Now this is sulfonated. Okay, so ये हमारा न्यूट्रल है. अभी न्यूट्रल को हम लोग को क्या करना है? we have to attach any acidic group into this polymer. So how we can attach? Either by doing sulfonation reaction or by doing carboxylation reaction. Okay, so here they have done the sulfonation reaction and you can see that SO3H group is attached here to the benzene ring at the para position. Similarly, here also you can see SO3H. Here you can see SO3H. Here you can see SO3H. Okay, so sulfonation reaction has been done with this styrene divinyl benzene copolymer and SO3H group is attached. Now this has become cation exchange resins. It has H plus ions which are responsible to exchange with the cations present in the water sample. Okay, so they contain which acidic functional groups like COOH, SO3H. So these functional groups will be get attached by doing carboxylation and sulfonation reaction. Carboxylation करेंगे तो COOH group attach होगा, sulfonation करेंगे तो SO3H group attach होगा. So by any method, by any reaction, we can add acidic group to this cation exchange resin and that will be responsible. And now what this they are going to give, ये क्या हो जाएगा आपका COOH group? COO minus H plus. So H plus ions are there in the acidic cation exchange resin. Similarly, SO32 minus and H plus ions. So that means cation exchange resins are rich in H plus ions. And that H plus ions will be exchanged with the hardness causing ions present in the water sample. And these are the examples of this cation exchange resin: Amberlite IR120, Dovex 50, Zeocarb, Diolite, Nelsite. Okay, so in market, when you will go to buy this cation exchange resin for suppose your filter which you have at home. Okay, suppose you have ion exchange filter at your home and you want to buy the cation exchange resin to fill in that. So when you will go into the market, if you will ask, I want cation exchange resin, they will not understand. So this is the market name of these cation exchange resins, that Amberlite IR120. आप अगर मांगोगे I want Dovex 50, so they will give you Dovex 50. You want Zeocarb, Diolite, Nelsite. Okay, so these are the examples of this cation exchange resin. So basically they look like this. They are the granules of the polymers. Okay, ये आपका पॉलीमर का ग्रैन्यूल्स है, रेजिन्स जिसको हम बोलते हैं. So these resins we are going to use for cation exchange. Is it clear? Understood cation exchange resin? Yes, students.
Yes, ma'am.
Okay. Anyone please tell me now if you have understood what this cation exchange resin will do. Yes? Who will tell me? What this cation exchange resin will do? इसका फंक्शन क्या है? ये क्या काम करता है? Yes, बेटा बोलिए.
Sir, it's capable for exchanging their H plus ions,
Yes, with
cation present in water.
very good. And which are the cations present in water? Which are the cations present in water?
COOH plus
O3H.
COOH.
नहीं, cations present in water. Which are the cations present in hard water sample?
H plus.
हाँ, आपकी वॉइस ब्रेक हो रही है. Which are the cations present in the water sample?
Calcium, magnesium.
Calcium,
Yes.
magnesium.
Yes. Calcium, magnesium, iron, sodium, aluminium. Okay. So, very correct said that the cation exchange resin will exchange their H plus ions with the cations of hard water sample, that is calcium, magnesium, iron, etc. Okay. तो ये चीज आपको इसमें याद रखना है. Now, we are going to move to the next, that is another type, that is anion exchange resins. Okay, so the function of these anion exchange resin will be they are going to exchange only anions from the hard water sample. Okay, now which are the anions present in the hard water sample? Cl minus, SO3 minus, SO3 2 minus ions, then carbonate ions, CO3 2 minus, bicarbonate, HCO3 minus ions. So whatever these anions are present in the hard water sample, only they will be exchanged with anion exchange resin. Okay, तो इसका काम रहेगा ये anions को ही exchange करेगा. अब इसके पास क्या present है? What this anion exchange resin? They are also polymers only. Which polymer we will study now? But they are abbreviated as ROH or ROH twice. Okay, these anion exchange resins, they are abbreviated as ROH or ROH twice. Now these anion exchange resins, they are rich in OH minus ions. Okay, they are rich in OH minus ions. Now again, these OH minus ions are actually not present in this resin. The resin is neutral, but we have to introduce some alkaline groups into this. जैसे वहां पे acidic functional group attach किया है, वैसे ही यहाँ पे हमको alkaline functional groups attach करना है into the resin. Okay, so after attaching this alkaline functional groups, either by doing reactions, we will get OH minus ions in these resins. So they are rich in OH minus ions, and they are going to exchange their OH minus ions with the anions of hard water, that is chlorides, sulfates, bicarbonates, carbonates, these ions. Okay, so here कौन सा रेजिन हम लोग यूज कर रहे हैं एज एनायन एक्सचेंज रेजिन? डाइविनाइल बेंजीन. ओके, these are divinyl benzene or amino formaldehyde copolymer. So these resins can be used as anion exchange resins. कौन सा? Divinyl benzene भी use कर सकते हैं, और we can use amino formaldehyde copolymer. Now, again, as I told you, these polymers, these resins, they are neutral, and we have to do some treatment with this. We have to add some alkaline group into this resin. So how we are going to add this? So these polymers, they will be treated with dilute NaOH solution. Okay, so that the OH group will be attached to this anion exchange resin, and that will be capable of exchanging their OH minus ions with the anions of water. Okay, तो इनके पास क्या है? anion exchange resin के पास क्या है? In what they are rich? They are rich in? Yes, students.
OH.
OH, not H plus, OH minus. आपका cation exchange resin है, they are rich in H plus ions. Anion exchange resins are rich in OH minus ions. So they are going to exchange their OH minus ions with the anions of water. Now, which are the anions of water? Cl minus, SO3
Carbonate.
2 minus, carbonate, CO3 2
Bicarbonate.
minus, bicarbonate, HCO3 minus. ओके, सो ये सारे एनायंस जो प्रेजेंट है वाटर सैंपल में, उसको वो एक्सचेंज करेगा OH माइनस आयंस से. लेकिन ये OH माइनस आयंस इसके साथ रेजिन्स के साथ था नहीं. वो कहाँ से लाया हमने? हमने वो रेजिन को डाइल्यूट NaOH के साथ ट्रीट किया, तो ये OH आयंस उसके अंदर अटैच हुआ. ओके, सो दिस इज वन एग्जांपल ऑफ द divinyl benzene polymer or resin, which you can see that there are OH minus ions attached to this. So we have treated this resin with NaOH. So OH minus ion has been attached. So this is alkaline. This is not acidic. This is alkaline. They also contain amino group. You can see N group is also there. OH minus ions groups are there. So basically these ion exchange resins, they are containing basic functional groups. So they contain basic functional groups like amino group, NH2, quaternary amino group, N, quaternary phosphonium, tertiary sulfonium, hydroxyl, etc. So these are the basic functional groups which are attached to this anion exchange resins. जैसे वहां पे हमने in acidic, which were the groups? Acidic, COH, SO3H, they were the acidic functional groups attached. Here they are the basic functional groups attached to the resin, that is amino group, OH minus, hydroxyl group, etc. And these are the examples of anion exchange resin, that is Amberlite 400, Zeolite FF, Dover 3. ये सारे market में available है anion exchange resins. So we can buy these anion exchange resins to put it into the filters. Okay, so they are also in form of granules. Okay, is it clear, students? Any doubt to anyone in the type of ion exchange resins?
No, ma'am.
Other students? Only one is not having doubt. Rest all is having doubt?
No, ma'am.
Okay. Okay, so there were two types of ion exchange resins, cation exchange resin and anion exchange resin. Cation exchange resin सिर्फ cations को exchange करेगा H plus ions से. Anion exchange resin सिर्फ anions को exchange करेगा OH minus ions से. ठीक है? Now we will move to the process of ion exchange. Okay, so this is the actually the process which is happening, and this is the diagram of the apparatus in which we do the deionization or demineralization process. तो ये हमारा tank है. There are two tanks, or you can say columns. Okay, this is the first column, this is the second column. Okay, बड़े बड़े towers दिख रहे हैं आपको, and they are made up of steel. Okay, so now you can see that we have different layers in that tank or column. We have at the bottom gravels layer. Okay, what do you mean by gravels? Gravels का मतलब क्या होता है बेटा? पत्थर. Okay, छोटे छोटे पत्थर. तो यहाँ पे आपका नीचे सबसे पहले ग्रेवल्स लेयर है, उसके ऊपर सैंड लेयर है, उसके ऊपर आप देख रहे हैं यहाँ पे कैटायन एक्सचेंज बेड है. ओके, सो नाउ दिस व्हाट डू यू मीन बाय दिस कैटायन एक्सचेंज बेड? Whatever the we have studied now, the cation exchange resins जो आपने देखा ग्रेन्युलर फॉर्म में है, वो सारे ग्रेन्यूल्स को हमने इसके अंदर फिल कर दिया है. ओके, तो सब ये आपका टॉप लेयर है. उसके नीचे आपका सैंड लेयर, ग्रेवल्स लेयर, डिफरेंट लेयर्स विल बी देयर, एंड एट द टॉप वी विल हैव कैटायन एक्सचेंज बेड. वी कॉल दिस एज द कैटायन एक्सचेंज बेड. तो इसमें से जब आप हार्ड वाटर सैंपल पास करोगे, वो सारे कैटायंस को एब्जॉर्ब कर लेगा और वाटर में हमारा H+ आयंस आ जाएगा. ओके, देन in the second column you can see that there is again gravels layer, and above that will be sand layer, and then anion exchange bed, anion exchange layer, resin layer. So again they are in form of granules, which we have already seen. They have OH- ions with them. Cation exchange resins, they have H+ ions with them. Okay, they are rich in H+ ions, and anion exchange resins are rich in your OH- ions. Okay, you can see that there are some inlet and outlet also with this tower, or sorry. So here you can see this is the inlet for hard water sample, and there are two outlets. This is one outlet and this is one outlet. One outlet is going to the sink, other outlet is going to the next column. Okay, next chamber. So again here in the second column, this is the inlet, and this is the outlet for soft water, and this is the outlet which is going into the sink. Okay, now as we know that this cation exchange resins, they are rich in H+ ions, and anion exchange resins, they are rich in OH- ions. So now what will happen? We are going to pass some amount of hard water sample on these beds. हम लोग हार्ड वाटर सैंपल लिए, सपोज 100 liters ऑफ हार्ड वाटर सैंपल इज देयर, एंड दैट वाटर वी आर गोइंग टू पास फर्स्ट. कहाँ से हम लोग पास करेंगे? वी आर गोइंग टू पास थ्रू द कैटायन एक्सचेंज बेड. तो हम लोग यहाँ से स्प्रिंकल कर रहे हैं. सी, दिस इज अ स्प्रिंकलर, हार्ड वाटर स्प्रिंकलर. ओके, तो वहां से हमने हार्ड वाटर पास किया. कहाँ पे? कैटायन एक्सचेंज बेड में. हार्ड वाटर सैंपल कंटेन्स cations as well as anions. Cations कौन कौन सा? Calcium, magnesium, iron, etc. And anions we have chloride, sulfates, nitrates, etc. Okay, so all the cations of hard water like calcium, magnesium, etc. they will be trapped in this cation exchange bed, and along and in spite of that, the H+ ions, equal amount of H+ ions, huh? जितना कैल्शियम मैग्नीशियम यहाँ पे आपका ट्रैप हो रहा है, the same amount of H+ ions from this cation exchange bed will move along with the water into the next chamber. समझ में आ रहा है बेटा? Yes, students?
Yes, ma'am.
Okay.
Yes,
Okay. So all the water sample containing cations will be accumulated in this cation exchange bed. That is calcium, magnesium पूरा आपका यहाँ पे आ जाके जमा हो जाएगा. And instead of calcium, magnesium, which is present in the hard water sample, H+ ions from the cation exchange bed will move with the water sample. Now here anions of the water sample is not removed. Anions are already it's there. Okay. आपका जो उसमें क्लोराइड्स है, सल्फेट्स है, नाइट्रेट्स है, वो है, उसको कैटायन एक्सचेंज बेड ने टच नहीं किया है. सिर्फ क्या किया? उसने कैल्शियम और मैग्नीशियम को ट्रैप कर लिया है, और उसकी जगह पे उसने अपनी तरफ से H+ आयंस डाल दिया उसमें, पानी में. ठीक है, तो नाउ द वाटर विच इज कमिंग आउट फ्रॉम दिस बॉटम आउटलेट, सो दैट वाटर इज containing H+ ions as well as all anions. So now this water has to be pumped with the help of vacuum pump. It is pumped into the second chamber, where again it is sprinkled over anion exchange bed. Okay, now this anion exchange bed is having OH minus ions, and the water sample is containing chloride, sulfate, nitrates. So now when this water is coming into this bed, anion exchange bed, all your chloride, sulfate, nitrates will be trapped into this, and instead of that, equal amount of OH minus ions will be liberated. Equal amount. जितना आपका कैल्शियम मैग्नीशियम ट्रैप हो रहा है उतना ही H प्लस आयंस पानी में जा रहा है. जितना आपका क्लोराइड, सल्फेट, नाइट्रेट ट्रैप हो रहा है पानी में, उतना वो रेजिन में, उतना ही आपका OH माइनस आयंस उसमें से निकलेगा. Okay, so equal amount. So equal amount of OH minus ions will be liberated along with the water sample. So now from the second column, the water which is coming out from the bottom outlet, that is containing 2 ions only. Which 2 ions? Can you students tell me? Which 2 ions are present in the water sample now? The water which is coming out from the second chamber or second column, that contains 2 ions. Which are the 2 ions? Yes?
H plus OH minus.
Yes, H plus and OH minus ions. अब पानी के अंदर हमारा क्या रह गया है? जो कैटायन एक्सचेंज रेजिन ने H प्लस ऐड किया वो, और एनायन एक्सचेंज रेजिन ने OH माइनस ऐड किया है वो, और जो भी कैल्शियम मैग्नीशियम था वो कैटायन ने रिमूव कर दिया, और जो भी क्लोराइड, सल्फेट, नाइट्रेट था वो एनायन ने रिमूव कर दिया. सो नाउ द वाटर विच इज कमिंग आउट, दैट इज सॉफ्ट वाटर फ्रॉम द आउटलेट, दैट इज रिच इन H plus and OH minus ions, and they combine together to form water molecule. Okay, so now the water which is coming as soft water does not contain any hardness causing salt. It is soft water containing only H plus and OH minus ions. Okay, so this is the process. Now, just a minute. Yes. So now what will happen? Suppose we have softened 1,000 liters of water or million liters of water from this type of filter. Basically, this is a filter only, where we are removing all the cations and anions of the water sample and making it soft. So it is a type of filter. So if suppose millions of liters of water have been softened from this apparatus, now what will happen? जैसे हम लोग अगर सुबह से शाम तक लेक्चर लेते रहते हैं, आप भी सुबह से शाम the call in between, that's why I got disconnected. Is it clear? My voice is clear now?
Yes, ma'am.
Yes, ma'am.
Okay. So I was telling that when you work whole day, you are attending the lecture practicals from morning till evening, till 4 o'clock or 5 o'clock. So you get exhausted at the end. ठीक है, थक जाते हैं, हम लोग भी थक जाते हैं, आप भी थक जाते हैं. फिर उसके बाद आपके पास कैपेसिटी नहीं बचता कि आप और बैठ सके. सपोज मैं आपको बोलूं बेटा आई विल टेक लेक्चर फ्रॉम 6 to 7 टुडे, extra lecture. So you will say, madam, we have got tired from morning till evening, we have attended the lectures, we have got exhausted and we will not be able to understand the things, our capacity has been finished. Okay, so here also this cation exchange bed and anion exchange bed, they get exhausted by softening a certain amount of water. Okay, वो कितना अगर सपोज मिलियन लीटर्स ऑफ वाटर हम लोग ने इसमें से सॉफ्ट कर लिया, उसके बाद क्या होगा, इसके अंदर जो भी आपका H प्लस आयंस था वो पूरा रिमूव हो गया है, और सिर्फ उसके अंदर कैल्शियम मैग्नीशियम आके पूरा आपका ब्लॉक हो गया है. एंड इन एनायन एक्सचेंज बेड all your OH minus ions has been removed and only your chloride, sulfates, nitrates have been stuck into that anion exchange bed. Now their capacity is lost. The cation exchange bed's capacity is lost and anion exchange bed capacity is lost. Now they are not able to exchange their H plus ions or OH minus ions with the so now what we have to do, have to फिर हम लोग क्या करते हैं, अगर हम थक जाते हैं तो क्या करते हैं? Yes, students, when we get exhausted, to make ourselves charge, what we do, what activity we do? क्या करते हो आप लोग? शाम को थक के, क्लास पूरा खत्म हो जाता है, थक जाते हैं, उसके बाद क्या करते हैं? Yes,
We play.
Red Bull.
okay, you play to get charged, then you take rest. कोई कोई लोग रेस्ट करते हैं, रात को अच्छे से सो जाते हैं ताकि सुबह फिर से फ्रेश रहेंगे क्लास अटेंड करने के लिए. Okay. Similarly, here also we have to make the cation exchange bed and anion exchange bed charge. Okay, तो चार्ज करना मतलब हमको वापस कैटायन एक्सचेंज बेड में क्या चाहिए? H प्लस आयंस. एनायन एक्सचेंज बेड को क्या चाहिए? OH माइनस आयंस, क्योंकि उनका सारा H प्लस एंड OH माइनस आयंस खत्म हो गया है. जैसे हमारी एनर्जी सुबह से शाम तक खत्म हो जाती है, वैसे इनका भी H प्लस आयंस एंड OH माइनस आयंस they have got finished.
Ma'am, another
Yes,
lecture
beta.
has begun.
Yes.
Another lecture.
Okay, another lecture. Just a minute, I will take the attendance. Okay, तो हम लोग यहाँ से नेक्स्ट क्लास में स्टार्ट करेंगे. Okay, just a second. Roll number 1.
Present, ma'am.
2. Roll number 2. Faiza. नहीं है. 3. Abdul Qadir.
Present, ma'am.
4. Alekar Hasib. Not there. 5. Ankit.
Present, ma'am. Present, ma'am.
Yes. 6. Abdul Manan. 6. Abdul Manan.
Present, ma'am.
7. Mohammad Anas.
Present, ma'am. Present,
Okay.
ma'am.
8. Deshmukh Mohammed. Yes, Deshmukh Mohammed. Present. 9. Faki Anas.
Present, ma'am.
Present. 10. Faruqi Farhan. Faruqi Farhan.
Present.
Present.